Hi everyone, welcome. We are so excited to have you here as you start your journey towards New York City Specialized High School Admissions Test SHSAT. In this video, we're covering a math lesson to build the foundation you'll be needing to get a top score. Before we begin, be sure to have a pen and notebook ready with you because we'll be talking about many tips and strategies throughout, so make sure that you do have all of the necessary equipments so that you can note down anything that you find important. Also, if you cannot afford expensive tuitions, don't worry. Our free lessons and practices are more than enough to help you prepare completely for your exam. Plus, our app also offers a predictive test, which is going to give you a realistic feel of what the exam is going to feel like. Now, let's get started and take the first step towards landing into one of New York City's specialized high schools. So like I said before, if you would want more practice materials, make sure to download our SHSAT Prep app from Apple App Store, where you are going to find lots of different practice materials so that you do not need expensive tutoring anymore. Without any further ado, let's get ahead with the video. So in this lesson, we're going to learn exponents, calculate numbers with exponents, square root, scientific notation, and addition, subtraction, multiplication, and division, the basic arithmetics using scientific notations. So pay proper attention to these questions because there are just a couple of formula that you need to remember, and these are actually fairly easy because generally we don't have word problem questions with these. Okay, so let's start. First of all, evaluate. So as we can see, we have a -7 to the power of 3, and then we have a 7 to the power of 4. So one of the formulas of this is, if you, let's say, have a to the power b times a to the power c. So what you do is, if the bases are the same and if you have multiply like this, the powers are going to be added. Okay, and vice versa, if there's a division, then in the power is going to be a subtraction. So let's just look at this question. First of all, -7 to the power of 3. Whenever you have negative and negative and it's like thrice, so let's just try to do this. Okay, negative and negative makes positive, and then positive and negative makes negative, right? So can I write this as -7 to the power 3? We can, right? And then times 7 to the power 4. So of course, now that the bases are the same, we are going to put the negative sign as it is, 7 as it is, and in the power, I'm going to add 3 and 4. So that gives us -7 to the power of 7. Okay, that's it. And whenever they tell us to evaluate, unless they tell us to find the entire number, we need to keep my answer just in this format. Okay, just keeping in the shortest form possible. All right, next, here's another question. First of all, let's just get this clear. For any real number n, so if n is any real number, in that case, what happens is, if it's a to the power 0, what that means is it's a to the power n minus n. Okay, and how did you get this n minus n? Remember what I told you, that if there's a division sign, it's automatically minus. So n minus n came from n divided by n, and if you want to do it in this way, basic algebra tells us that my answer is going to be 1 because canceling it out give me 1. Okay, so even if we consider n to the power 0 or anything to the power 0, in that instance, it's always going to be 1. So here is another formula that you can keep in mind. A to the power 0 or anything to the power 0 is always 1. Okay, all right, moving on. So here's a practice question for you, like we do in all the rest of our lessons. You can take a screenshot of this, or you can pause and you can try to solve this on your own. I hope that you do get 256. Is exactly like what we have been doing so far. All right, moving on. So we have 7a over 7b. Just like I told you, if the bases are the same and the powers are different or the same, doesn't really matter. If there's a division sign in the middle, we do subtraction. If there's a multiplication sign in the middle, we do addition. So this means that, of course, because 7 and 7 are the same, it's the bases that are the different, and we have a division in the middle. All it means is it has to be a negative in the power. Okay, that's your final answer. Okay, so if you did get that correctly, we have the bases same, 5 and 5, but most definitely in the powers, they're different, but even if they weren't different, it really does not matter. So what we do here is we do subtraction. We do 15 minus 18, which gives us 5 to the power of negative 3. Okay, another thing that you need to remember when we do indices is if you have anything as a negative power, that basically means 1 over the rest. So let me just write it down for you. If you have a to the power of negative b, it means 1 over a to the power of b. So in this case, 5 to the power of negative 3 means 1 over 5 to the power of 3, right? So what's 5 to the power of 3? That's 5 times 5, which is 25. And again, 25 times 5, that is 125. That's your final answer. Okay? So here we are introduced to another different formula. Let's look at this question once again. Another practice question. Make sure that you do remember the formula while you're doing it. Let's move on. So here we have a huge parentheses over the entire thing. What that means is this entire parentheses 3 is being multiplied to all of these powers, okay? So first of all, let's break down the parentheses first. Then we're going to incorporate the 3 with it. So we have a 2 to the power of 3 already. And on top of that, we have another 3 right now. Times, you have a 3 to the power 2 already. You have a 3 with that. You have a 6 to the power of 3 already. You have a 3 with that. So 2 to the power of 3 times 3, that is 9. 3 to the power 2 times 3, that's 6. And 6 to the power of 2 times 3, that's 9, right? Now, if you look at this properly, in the numerator, you have 2, you have a 3. So we know 2 times 3 is 6. In the denominator, you have 6. So what you can do is, in the denominator part here, in the case where you see a 6, what I can do here is, I can actually write this as 2 to the power 9 times 3 to the power 9. Got it? And why am I doing that? The only reason is so that I can simplify it according to the numerator. All right? So in the case of 6, I broke it down into 2 and 3. So now I can simplify this with this. But in this case, you have 3 to the power 6 divided by 3 to the power 9. Once again, because the bases are the same, the powers will now be minus. It has to be a subtraction in the middle. Right? That gives me what? 3 to the power negative 3. And remember what we did earlier? If it's a to the power of negative b, that turns out as 1 over a to the power b. So now 3 to the power minus 3 means 1 over 3 to the power 3. So 1 over 3 to the power 3 is 27. So that's my final answer. 1 over 27. Okay? Moving on. So here we have another question, 2 to the power 7 times 3 to the power 11. So if you look at this properly, you have 2 and 2 that is common. You have 3 and 3 that is common. So first thing that I'm going to do is I'm going to separate them, because that is, of course, going to make it easier for me to solve later on. And now, if you look at this properly, you have the bases 2, which are common. And because there's a division in the middle, what I can do is I can do 2 to the power 7 minus 5, just like this. And then you have a 3 to the power 11 over 3 to the power 14. So that makes us 11 minus 14, right? So now 2 to the power 7 minus 5 is 2. 3 to the power 11 minus 14 is minus 3. So 2 times 2 is 4. And 3 to the power minus 3 is exactly what the previous question said, which was what? 1 over 3 cubed. I'm putting it to the right side now. So that's 4 times 1 over 3 cubed is 27. And if you solve this, it's just going to be 4 times 1, which is 4 over 27. That is my final answer. Okay? So far, so good. Now, we have another practice question. Once again, it's the same. You can try to bring out 64 as 2 to the power of something. Just give you a hint. That way, you can simplify those. And you have 3. You can bring out 15 as 3 to the power of 5. Sorry, 3 times 5 as 15. And then you can continue. Okay. Hope you do get a half by the end. All right. Let's move on to the next question. So here we have decimals. Nothing to fear. It's the same. Just like we see 0.4 to the power of negative 2, we know anything to the power of negative anything means 1 over that to the power of that, right? So first step, we can write 1 over 0.4
whole squared divided by, you can write 1 over 0.6 whole squared, right? Now what? Now 0.4 squared can be, you can actually write 0.4 squared as, because 0.4 is what? 4 times 4, which is 16. So 0.4 squared is going to be 0.16. Got it? And once again, 1 over 0.6 squared is 6 times 6 is 36. So that's going to be 0.36. Now you can flip it if you want to, because that's how we do it. In the division sign, if it turns to multiplication sign, it's going to be 0.36 over 1. And now you have 0.36 over 0.16, right? So 0.36 over 0.16 can just be written as 36 over 16. Why? Because if I remove the decimals, I needed to multiply 100 with either of the numerator and the denominator, and doing that will eliminate the decimal. So that gives me 36 on top and 16 on the bottom. Now all you do is you can try breaking it down with 4, because 4 times 9 and 4 times 4. So now you can actually divide it like this. 4 2s are 8. Then put a 0. 4 times 2 is 8. Once again, that gives me a 2. So 4 5s are 20. So my final answer is 2.25. Okay? All right, moving on. Here we have another example. So first of all, what you can do is, if you remember PEMDAS, so PEMDAS tells us that whenever we look at a parentheses, the first step we do is we solve whatever we see inside the parentheses, right? So in this case, you do 2 plus 0.1 first. So 2 plus 0.1 is what? That's 2.1. So that's 2.1 squared minus 100. Now what you can do is, you can do 2.1 squared separately. So what's 2.1 squared separately? To do that, what we can do is, we can do 21 times 21. So that's 1 and 2. And then 2 times 1 is 2. 2 times 2 is 4. And now if you add these, 1 4 4, and if we look at the decimals, it was a 2.1 here, 2.1 here. So there are 2 numbers next to the decimals, right? 1 number each. That means there has to be a decimal starting from the right to 1 unit, 2 units. Yeah, exactly, right here. So that gives me 4.41. So in that case, my value for 2.1 squared is now 4.41. Now what you can do is, if you do 4.41 times 100, what does that mean? That means, once again, you are going to remove the decimal. Remove the decimal to how many units? To 2 more units. So that gives me what? 441. So 441 minus 100 is just 341. Okay? All right, let's move on to the next question. This looks complicated, but trust me, if you just break it down to the ways in which we have already learned, of course, it's going to be very easy to get 109, all right? So practice this on your own. Let's see. All right, so now we have square roots. First of all, let me teach you how to break square roots. So what you do here is, you take the number 3675 and you take the smallest possible prime numbers with which you can divide. So prime numbers are the numbers which you can divide itself with, or you can use 1 to divide it. So starting with 2, not with 1, because 1 gets only divided by 1. So if you go for 2, 2 gets divided with 2 and also 1, right? So these are prime numbers. You cannot divide prime numbers with any other number. So 2 is a prime number, 3 is a prime number, not 4, because 4 gets divided with 2, right? So not 4. And again, 5 is a prime number. So if I want to divide 3675 with the shortest prime number, which is 5, what happens? So if you want to, you can do this individually, separately somewhere else, okay? I'm just going to write it here. So 3675. 5 times 7 is 35. So that's 17 here. 5 times 3 is 15. Then you have 25, so 5 times 5. So that gives me 735, right? So that's 735 here. Once again, you can do 735 divided by 5, 5, 1. So that's 23, 5 times 4. So that's 20. Subtracting gives me 35, so 5 times 7, yeah? So you have 5 here, you have 147 here, okay? So now what? So 147. You need to now think about what actually gives us this 147, okay? So let's try to figure that out. So if you look at other numbers, not 5, not 2 or 3, if you look at 7, can 7 divide 147? Yes, it can. Why? Because 7 times 2 is 14, 7 times 1 is 21, right? So doing that can give me 21, and once again 7 times 3 is 21. Okay, if you did get till this point, wait, let me just erase some stuff so that there's space for us to do the rest. Okay, just trying to make it neat so that you do understand if you want to take screenshots later on. All right, let's continue. So in that case, what does root over 3675 give us? It gives us 2 5s, so we're just going to write 5 squared. It also gives us 2 7, so we are going to write 7 squared. And it gives us 1 3. Okay, so now what? You need to remember that square and square root can cancel each other out. Okay, so this square root and this square canceling out gives us 5. Square and this square root canceling out gives us 7. But does 3 have a square? No. So it's just going to be square root of 3. Okay. So now what? Now we have 7 times 5 is 35. So that's 35 root 3. So what are the values for P and Q? Because it's in this format already, right? So as we can see, P is equivalent to 35 and Q is equivalent to 3. Okay, I did take some time to explain it to you because you might not know square roots from before. Let's move on to the next question. So here we have root 5 plus 2 root 5 to the power of 4. Just like PEMDAS, the first step is to figure out what is inside the parentheses. So let's say in the case of root 5, had it been x, if it had been, let's say, x plus 2x, what would we have written? We would have written 3x, right? Same with this, okay? If it's root 5 plus 2 root 5, that makes it 3 root 5, okay? 3 root 5 to the power of 4. Now what? Individually, that means it's a 3 to the power of 4 times it's a root 5 to the power of 4, okay? Another thing that you need to remember before this is, what is root 5? Root 5 is basically 5 to the power of half, okay? So anything that you see a square root of, that means it's 1 to the power of 2. So let's say if it were a cube root, that means to the power, it's going to be 1/3, all right? So now we can actually write root 5 as 5 to the power half. And once again, we have a 4 here. So I think by now you'd know what I'm going with this. So 3 to the power 4 is 3 times 3 times 3 times 3. So 3 times 3 is 9. 3 times 3 is 9. 9 and 9 is 81 times 5 to the power of, if I simplify this, that gives me 5 squared, which is 25. So just do 81 times 25 individually. That gives you 2025. All right. Okay, so let's move on to the next question. We have a practice question here. I hope you do get these correctly, just like the 2 maths that we have done so far. What is the scientific expression? Okay, so here's another topic, okay? Let me just first give you an overview. Scientific expression is whenever you have a very big number, sometimes in calculators, it's not possible to put in digits that are over, 10 digits. So in that case, what you're going to see is, you're going to see times 10 to the power of something, okay? Let's say if you have 2 and 8 zeros. So that means it's 2 times 10 to the power of 8. If the calculator or if whatever digit or whatever, device you're working on, if that does not fit in the number of digits, so then you're going to see scientific expressions like this. So for scientific expressions, the step for this is you need to move the decimal right after the first number. So that is your goal. And like I told you before, whenever a number is like this, let's say it's 100, right on the bat, we don't see any decimal on 100, right? So what you do here is you need to imagine that there is a decimal next to the entire number. and you need to drag it to the point where it's right next to the first digit. So in this case, with 10,307, we don't see any decimal, which means that there is a hidden decimal right next to the entire number. So we need to drag it how many units? 1, 2, 3, 4. We need to drag it 4 units to the left. Dragging it 4 units to the left now gives me this, right? So moving the decimal point to any units to the left will give me a positive power, and because it's 4, that gives me positive 4 in the power. However, had it been the other way around, let's say if it were, let's say I'm just giving you an example, let's say if it were 0.5, of course we knew that we need to put the decimal 1 unit to the right, because the decimal is always 1 digit right next to the first digit. So if that's 5 now, it should be what? It should be 5 to the power, 5 times 10 to the power negative 1. Why negative? Because moving it to the right gives me a negative power. Okay? If you didn't understand this, we are going to do some more questions. Just like that example that I showed you, we have 0.00038. So the decimal goes right next to the first digit. So the first digit, we are going to consider that as 3 because we don't count the zeros. So let's move it now. 1, 2, 3, 4. So that's 4 units to the right. So that's 3.8 now times 10 to the power. 4 units to the right gives me negative 4. Okay? I hope this is easy for you now. So once again, here is another one. Basically, there is already a decimal given here right before 2. So you put it next to 7. And then I hope you do get this right. Okay. Now it's the other way around. So if you have a number that's already in those units, how do you write it in standard form? So how do you write it in that complete form, okay? So what 8.32 times 10 to the power 5 means is 8.32, in this case, you need to put, because it's 10 to the power 5, you need to put the decimal 5 units to the right. So that's 1, 2, 3, 4, 5. So the decimal now goes here. So what happens to these empty spaces? We are going to put zeros here. So my answer is 832 and then 0, 0, 0. Okay? So we basically did the other way around. Now if we see a negative number, what do we do? Negative number means we need to put it, yes, you guessed it right, to the left. How many units? 3 units. So 1, 2, 3. So we now have the decimal here, which means that in the gaps, we are going to put zeros. So that's 0.005034. And what happens right before the decimal? There's nothing. So we put another decimal. Okay? That's your final answer. All right. Now, yeah, we have another practice question. Let's see. So here we see 2 numbers and we have something to add in the middle. So first of all, what we can do is we can assure that they do both have the same exponent, because we have 10 to the power 6 here, we have 10 to the power 7 here. So what if we convert this 10 to the power 6 to a 10 to the power 7? So what we want to do here is, because it's a 3.2 times 10 to the power 6, let's say if we did move it to 1 unit to the left, what would we have done? We would have done, because it was a 10 to the power 6, we would have done a plus 1, right? So doing that gives me what? So doing that now gives me 0.32 times 10 to the power 7. Got it? And it was already a 2.5 times 10 to the power 7 to start with. Why did we do this? So that we can take 10 to the power 7 as common from both of these. We are now taking 10 to the power 7 as common, and in parentheses, we can just do 0.32 plus 2.5. Okay? Now that gives me what? 0.32 plus 2.5 is 2.82. So my final answer is 2.82 times 10 to the power of 7. Okay? Moving on. So here we have, once again, a similar set of questions. So what we can do is, because this is 10 to the power negative 3, this is 10 to the power negative 4, trust me, removing either one, as in, you can convert this 10 to the power negative 3 as 10 to the power negative 4, or the 10 to the power negative 4 as 10 to the power negative 3. Both are fine, okay? So let's just do the opposite now. Let's just convert this as 10 to the power negative 3 now. So because it's 5.64, if you want to convert that to a 10 to the power negative 4, if you want to convert that to a 10 to the power negative 3, what you do here is, once again, put that to 1 unit to the left. So that gives me 0.564, right? So let's now write the entire thing down. 2.35 into 10 to the power negative 3 minus, now you're going to write 0.564 times 10 to the power negative 3. Okay. You can now take 10 to the power negative 3 as common. And in parentheses, you can write 10 to the power 2.35 minus 0.564. 564. Okay. Now you just do this in our basic format. I'm still going to show it to you just in case you might have a hard time subtracting this. There's basically, also I'm just saying, there's another video where I show you addition, subtraction, multiplication, and division with decimals. So if you have not watched that lesson yet, make sure you do. And now, how do you subtract this? So basically there's nothing here. So let's say that's a 0. So you take that as 10. So 10 minus 4 is 6. Now you cancel, you make this 6 as a 7. You take that as 15. So 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 8. You convert that. You make 5 as 6. So you do 13 minus 6 is 7. You do that as 1. 2 minus 1 is 1. And then you put the decimal as it is. So that's 1.786. 1.786 times 10 to the power of negative 3. That's your final answer. Okay. Let's see. We have another practice question here. I hope you do get this one right. And now an example. So it's basically just like we did before, but we have multiplication in the middle, right? So let's first try to figure out what should we convert. So previously, had it been a plus and a minus based question, we would have tried to figure out how to convert 10 to the power 5 to 10 to the power 6 or vice versa. But because we have multiplication here, we don't need to worry about it. Why, you may ask? Because everything is getting multiplied here. You can write 10 to the power 5 with 10 to the power 6 together. And you can write these multiplications together. Wait, I am explaining it to you just in a sec. So here, if you remember, there was a rule for indices, which was a to the power b times a to the power of c gives us a to the power of b plus c. That means 10 to the power 5 times 10 to the power 6 is going to be 10 to the power 5 plus 6, right? And then times 8.2 times 2.6, you just do that individually here. All you do here is you do 82 times 26 first. So let's do that. 6 times 2 is 12. To carry the 1, 6 times 8 is 48 plus 1 is 49. 49, you write a 0 here. And then 2 times 2 is 4. 8 times 2 is 16. So that's 2 and 0 is 2. 9 and 4 is 10, 11, 12, 13. Carry the 1. 4 and 1 is 5. 5 and 6 is 11. Carry the 1. 1 and 1 is 2. So that's 2, 1, 3, 2. But because we have a decimal here, we have a decimal here. So there's 2 numbers next to the decimals. So it should be 2 units from the right. So my final answer is 21.32. So I'm just going to write 21.32 here. 10 to the power 5 plus 6 is what? 11, right? So you write 21.32 times 10 to the power 11. You might think that my answer is ending, but no, that's not my final answer. Why? Because in standard form, what we do is we need to put the decimal right next to the first digit, remember? So you need to make it 2.132. If you do that, you need to add 1. Because we moved 1 unit to the left, you need to add 1 to the power. So adding 1 to 11 gives me 12. So that is my final answer, okay? I don't think we have much left. Let's look at the next question. Okay, so we have an example here. 1.15 times 10 to the power 7 and 2.5 times 10 to the power minus 6. So before we start this, I would like to give you a recap on one of the indices, which said that if it's a to the power b divided by a to the power c, what we do here is we do a to the power of b minus c. Okay, so now what? Now you can write 1.15 divided by 2.5 individually. In the case of 10 to the power 7 over 10 to the power minus 6, you can write 10 to the power 7 minus 6. Okay. And now what happens to 1.15 over 2.5? So what happens here is you can actually remove the decimals by multiplying that to 100. So if you do that with 1.15 with the numerator, you also need to do that to the new denominator. And here, 10 to the power 7 minus and minus makes plus. So that is 7 plus 6. Okay. Now that is 115, and here we have 250. So 10 to the power 7 plus 6 is 13. So you do 115 over 250 individually, okay? If you do that in decimal, that's going to be 0.46 times 10 to the power 7 plus 6. No, my answer has not ended. Why? Because you need to put the decimal 1 unit to the right here. So that gives me 4.6. And because we moved it 1 unit to the right, we need to subtract 1 from the power. So 13 minus 1 is now 12. So that is my final answer. Okay. Let's see. I think that is the end of this particular lesson because we just have a practice question here.
So with that being said, that is the end of this lesson. Thank you so much for watching. And if you want more practice materials and videos like this, make sure to download our SHSAT Prep app from Apple App Store. You are going to find out a lot of practice materials, and at the same time, there's a predictive test waiting for you so that it's going to give you a real feel of what the exam is going to feel like. Thank you so much for watching once again. Make sure to check out our next lessons, and at the same time, subscribe to our YouTube channel for more.